our second day of Law with Cosines. Now, we talked a little bit before about if I had an angle and two off sides, how I could use this formula. You're like, that formula doesn't look much different from the last lesson we did, and it doesn't. The difference now is, though, I'm going to have no angles to work with. I'm going to have three sides. Here's the part that gets tricky, though, and the part that's not a big favorite of people when we do these. Because we talked a little bit on Friday, once you use the law of cosine, then you'd use the smallest side with the law of sines.
What did you use, Carter?
Oh, I just made that. It should have come up as a triangle shape, and it just got a little funny. Now what do I do if I'm given three sides? Oh, boy. Use the biggest one. You're like, wait a minute. So if I get sides, I have to use the biggest one. But if I'm using the law of sines, I got to use the smallest one when I'm doing this. Yes. And that's the one thing you've got to keep track of. I will give you this part when we're doing quizzes and tests, but you've got to know how to use it. So when we're doing number one here, I am going to start my adventure finding angle A because side A is the biggest one. And this is not optional. You can't flip around and do them any way you want, because sometimes there will be a very small difference in your answer, but other times it's going to be very, very large if you don't do it the same way. So you're like, well, wait a minute. I don't know the angle anymore. That's true. So we're going to fill in all the other numbers except this angle A that we're going to find. So we've got A squared equals, because we're just going to follow this top one right along, B squared plus C squared minus 2BC times the cosine of A. Now, some of you are probably wondering right away, or maybe you've already started playing on the calculator. I'm just going to start typing all this in. That's fine to a point, because I do want to go over some pieces of this with you. So we're going to break this down very slowly. When I get to the right side, here's how this breaks down. I'm going to do just the sum of the squares part first, and I'll explain why as soon as we get this all set up. And then I'm going to multiply the 2, the 19, and the 14. Because I don't know what the cosine is, so I can't even bother with that yet. So some of you may be saying, well, why didn't you just type in all of this stuff, and then you just put it in front of cosine A and you go on about your life? Here's why. This product, this 2 times 19 times 14, this is just strictly going with cosine. I like looking at it sort of like you'd look at it if you were solving an equation and you were treating the cosine of A sort of like it was x. Okay. So here's how we're going to be tackling this. We're going to be tackling this as though it were an equation, because the next thing that people do a lot on these is, oh, 557 minus 532, it's 25 cosine A. No, it's not. Just like this wouldn't be 25x. So my next job is going to be to get the 557 out of there. I need to isolate my cosine term. So when I subtract that over, which I'm going to do right here, so I'll get that over there, and now, just like I would if I were solving an equation, I'm going to divide by negative 532, because that's what I'm multiplying the cosine of A by. So I swing this over here. We'll do a little calculator work. And I'll actually write this step in so we don't get ourselves lost later. So I look and I go, okay, I'm finding an angle, so I'm going to remind myself of that with the negative 1. So I'm going to type, just like I did before, type in the fraction, get my value out. Yep, and with this, since I'm looking for an angle, I know that's not the angle. That'd be ridiculous for an angle. Second cosine, because I want the angle. And then I need to put that decimal in. And whether I type it in or I hit second negative to get that value. And we're going to keep going to the nearest tenth today. Okay, so angle A is 82.1 degrees. Now what we were doing Friday all comes back into play. We're going to use the law of sines to find the other parts. Remember, when you go to law of sines, we're going to use the smallest remaining side. And that's the part that's tricky about having three sides. You're like, dang, I used the biggest number for the first step. Now I'm using the smallest number for what's left. Because now when I'm using law of sines, I've got the corresponding angle inside. And then now I don't have a choice. I need to use side C next, which means I'm going to be locating angle C as my next value. Now this at this point should be old hand. This shouldn't be real tough because, oh yeah, I'm just doing the cross multiply thing. So I cross multiply the part that doesn't have my angle in it, and then I divide by whatever value was being cross multiplied with C. And I let the calculator do all the work. So it's nothing terrible, it's just watching the detail and making sure, like when I get here, I don't say, oh, it's a 63-degree angle. No, it's not. I need to find the angle by using second sine. So C then would be 39.1, and we finally get to the easy part, which is just taking 180 minus the sum of the two angles that I have.
Are we just doing a review?
This is dealing with a new thing because now we have no angles to play with. We're using the same formula, but we're just using it in a different way, is basically what we're up to here. But yeah, once we get past that first step, it's law of sines, which we've been doing for what feels like forever at this point, but it's only been about 3 days worth. So whenever we're starting to play with these, okay, and we're going to do number 2 as well because I just want to kind of get you used to all of this. But remember, the biggest thing here is remembering what parts you have to use. So like for instance on number 2, which side do I have to start with? I have to start with A because A is the biggest side. Now, it doesn't mean every time A is going to be the biggest side. It just happens to be in these first two. So I'm going to use the A squared version of my formula, and I'm just going to plug in all the values. So I've got A squared equals B squared plus C squared minus 2BC cosine of A, because I'm actually using it to find the angle this time. So the law of cosines is kind of nice. It can help you find sides and angles. Like we said before, when I was doing the first one, we have to do it in pieces though. So I'll get my left side set here. And then remember, we do just the sum of squares first. We'll do the other part after that. Because again, it's two separate terms we're working with there. I can't just plug that all in at once like I did before when I had the actual value of the cosine, at least of its angle. Okay, so I have to keep those separate. And again, I can't subtract 925 minus 756 because I treat cosine A like it's a variable. They're not like terms. So once I've cleaned up my bits and pieces and gotten things simplified, I'm going to subtract that 925 over. And then I'm going to divide by the coefficient of cosine A, which is negative 756. So, to find my angle, I'm going to do 596 divided by negative 756, and then use my second with that function. So, I mean, there's lots of places that things can go wrong if I'm not careful, but in theory, this shouldn't be too bad. That's one big angle. Okay, so 142 degrees goes with my side A. Reminder, once you get that, because you now have a corresponding angle inside, I'm going to be able to use the law of sines from here on out. But which side am I going to be using? The 14, because I have to use the smallest one now that I'm to the law of sines. Which means I am going to be finding angle B next. So just like we did back on the last one, cross multiply with your portion that doesn't have the B with it, divide by that B part, which will get me again my angle. Just be careful when you're getting everything in. Okay, get a decimal, which I would expect because I have to do second sine to get my answer. We're going to the nearest tenth. And then I can do the part I like, which is just 180 minus the other two.
You always do that?
For that third one, yep, once I have the first two, 180 minus the other two will work great every time. And that's not going to change for any of these. So again, as long as you keep straight, biggest side to start, smallest side when you go to law of sines, life's pretty good. So, how does this apply though when I get to the story problems? Yee. So that's where I want to head next. I want to hit those last two up because that'll get us some good practice doing this some more, but it also gets us into a little more of having to figure some things out. All right, so we're going to flip over to number 7. 2 radar stations 2.4 miles apart, okay, are tracking an airplane. The straight line distance between station A and the plane is 7.4. And the straight line distance between station B and the plane is 6.9 miles. Okay. What is the angle of elevation from station A to the plane? In other words, we want to find angle A. Now, it may not always be as easy as we would hope it would be. Because I start looking and I'm like, I'm going to call the plane's angle C up here, just so we're consistent with things. And label my other sides, just so I have an idea what's going on and I don't try to do anything I can't. Which side, or which, let me put it this way, which angle do I have to find first? I have to find B, I don't have a choice. I gotta go with the one with the biggest side. Even though A is the one I really want, I've gotta find B first. So, I take my B squared, and that's gonna equal the sum of the squares of my other two sides minus 2 times their product times the cosine of B, because that's the first angle I'm going to find. So as long as you remember when you get to the right side of the equation to separate over there, we should do all right. So Swing this guy over here. And this is going to be a little more realistic in that we're not going to get all these whole numbers that we're working with all the time. And just like we have on the first two, again, subtract this first number over. Don't touch that number that's hooked onto my cosine b here. So we'll subtract that 53.37 over. And then to find b, we're going to have the 1.39 divided by negative 33 and 1200ths. And that little tiny decimal number. Oops, let me get back there and get this in right. Here we go. And again, we're looking for the angle. So second cosine, because we're using the cosine right now. And take my answer. So we've got B is 92.4 degrees. So then comes the next question. Which angle do I find next? A, thank goodness. Because I notice, okay, of my remaining angle options, wait a minute. We just found angle B, so we used this up. Which one's shorter? C is. Like, really? So I got to find A last, and that's the one I want. Sometimes that's the way it works. Because again, when I go to cosine, if I don't go to the shortest one, I mean, when we go to law of sines, excuse me, misspoke there. If we don't use the shortest one, we're going to end up with a different solution. Might be a little off, might be a lot off. So here, when I go to law of cosine, I'm going to use my corresponding side and angle. And no, you won't get stuck every single time having to go through everything. And since C is the shorter side, that's going to be the angle we're going to find. So just like we've done every other time with law of sines, find the one that doesn't have the C, multiply those together. The one going this way, we're going to divide. Remember my -1 because I need to find the angle. There's my little decimal. We're now using sine, so be careful to use sine and not cosine. I get angle C, and now I can finally get what I'm looking for. Because A is just going to be 180 minus the sum of the other two. Finally figured out that angle of elevation. So stay patient. Don't try to jump to the angle or the side you want just because you want to be done, because all it's going to do is mess it up and have you probably... What's that? Sometimes you can. Yep, sometimes you will. Will it work every time? No. Sometimes it will, though. That's the tricky part.
Why won't it work every time as long as you have the other angle to work with? Sine A, cosine B, cosine C. If you have sine B and it's underneath, can't you...
Depending...
What to get A?
Because with the rounding that we end up doing, if we were using like exact angle measures, like we were taking that 18.9 out to 18.872, whatever. But by rounding, if I did, now in this case, it was close enough that if you rounded, it didn't make a difference because Darian found that out. If I do it though, and there's a large difference, like maybe it's 18.46 and I go back to 18.4, it'll change it enough that it'll change those, and then you'll be like, maybe you'd get like 68.9 or 69, which to us doesn't seem like a big deal. It's like 0.3, who cares? That'd be kind of bad. And I think this last one we're not going to have to worry about that anyway. So, all right, let's see what we got with this last one here. We got the Shady Pines Campground. Ooh, I have no drawing. Okay, well, let's read it first, I guess, just to make sure. Campsites A and B are situated 80 meters apart. Okay. A and B. 80 meters. The camp office, okay, we're going to call the camp office C, is 95 meters from campsite A and 115 meters from campsite B. When the ranger is standing at the office, what is the angle of separation between campsites A and B? In other words, find angle C, or find the angle of the office. So, let's see what we've got here. Which angle are we going to be locating? A. Biggest side when we're starting with law of cosines of three sides. So we're going to be finding this one. So A squared equals the sum of the squares of my other sides minus 2 times their product times the cosine of A, because that happens to be the angle that we're going to find. So then we jump into our maddening calculations. And again, as long as I make sure I just subtract the 15,425 first, don't try to do anything fancy like combine like terms or something, because there aren't any, I should be in pretty good shape. So I'm going to divide $2,200 by 15,200, and you're like, wait a minute, you didn't do the negatives, but negative divided by negative will be positive. But if I use the negatives, I'd get the same thing at the end anyway. And then again, since I'm using cosine, I'll use second cosine. Kind of important detail. So I get my angle A, which is 81.7, and I'm much happier this time because I go back and I look at my diagram and I say, well, what angle am I going to find next? Woo, I get to find C because there's my shortest side. So no having to do extra stuff this time. I've got my corresponding side and angle. And now I've got side C, and I'm going to find angle C, and I'm going to be done. Hooray, hooray. So again, there's my portion that doesn't have my variable, because I'm going to divide by it. And let's see what we get here. And we're dealing with sine. And I've got myself that value. Now there is one more thing I want to do with you, actually off the packet, because there's a couple of things that I just want you to be able to think about, and I want to help avoid some problems. So there were a couple of these, or at least one of them, that I wanted to make sure we talked about, because I didn't want you to get yourselves all fired up and not know what's going on. So a couple of hints to throw out there on helping out with the packet itself. So let's see here. So it starts with the Law of Cosines applications. I want to make a couple mentions here. One of them's on number 4 at the bottom of that first page. Now, they give me a lot of information. They give me this angle of walking in a 35-degree path along the road. Okay. After walking for 450 meters, okay. She turns 75 degrees and heads back towards the road. You're like, but wait a minute, the 75's out here. Weird. How far does she need to walk to get back to the road? Here's the hint I'm going to give you. If this is 75, what degree measure is this?
75. Wait, no.
105, because they'd be supplementary.
Oh.
That 105 could come in handy. Okay, so don't let that 75 suck you in and you start using it and then you're like, oops, that's not right. So one thing to be careful of. Next one I want you to be careful of. And again, also notice at the top of each of these pages they give you clues on what you're using. Law of Cosines on the first page. When we get to Law of Cosines, I found this out last hour. Some of us have forgotten some things about geometry class. For instance, they give me this parallelogram. They have lengths of 8 and 6 feet. Okay. That's not a big deal. The shorter diagonal, because we have to remember, it's going to have 2 diagonals. The shorter diagonal is 9.5 feet. Okay. So I'll put an 8 down here too and a 6 over here. Find the smaller angle of the parallelogram. Now here's where you have to be cautious. When you're looking for the smaller angle, that's the angle you're looking for, because you can even look at it and tell this is acute, this is obtuse, that's going to be smaller. So that may help a little bit when you're looking at this triangle with 3 sides, knowing that's the angle that you're looking for. Because I don't want you guys getting so caught up in some of the geometry of this in that way that it kind of messes you up. Let's see. There was 2 others I wanted to help with. Okay, that's one of them. Number 2, 5 degrees north of due west. I'm actually going to help you draw the picture on this one. Okay, so we're checking boaters on a lake to make sure they don't display the osprey nesting sites. She leaves a dock. Okay, leaves a dock and heads due north in her boat to the first nesting site. Okay, so we're heading north. When she gets to a certain point, this first site, she turns 5 degrees north of due west. That is a very fancy way of saying if you took a left turn, you'd be going 90, but you're going 5 degrees above that. So she made a 95-degree turn. Ew, that was kind of not nice. Travels an additional 2.14 miles to the second nesting site. She then travels 6.7 miles directly back to the dock. How far from the dock is the Osprey set? So I wanted to get you a picture on that, especially that 5 degrees north of due west. I even had to look at that for a minute. I'm like, wait a minute. Pictured it out and worked it. But I've got enough info there to be able to get what I need. I think the last one that I thought you could use some assistance on is on the back, the very last one. There's more hints at the top. Law of Cosines, side angle side. I'm trying to figure out some of these things. All right, there's the parallelogram again. Sides of a parallelogram have 18 and 26. One angle is 39 degrees. Okay. You're like, how do you know it's that one? Well, I could actually put it up here too. Again, having an idea, acute, obtuse, that's going to be 39. Find the length of the longer diagonal. Now, here's my question. When we're working with a parallelogram, see how far some of you can dig. What do we know about consecutive angles in a parallelogram? They're going to equal 180. So that lets me know that each of these is going to be 141, and now I have all the information I need. Because within the triangle I have an angle, and I have my two sides to work with. So again, draw pictures. Most of these have pictures, but otherwise draw pictures. Kind of work through it some. We'll have answers up tomorrow. We'll have a chance to go through some of that. And we're going to be going through the quiz preview as well. But you've got to jump into these now. You cannot wait, especially since the homework check is coming soon.